Okay, so welcome back, and now we're going to do another example of, this is going to be an example of a two-loop Limacon. So, what are we going to do first? Well, let's follow the steps. So first of all, notice that A is less than B. So that means that this is going to be indeed be a, what do we call it? Inner loop Limacon, or a two-loop Limacon. So first things first, what? Test for symmetry, right? So again, I know this is going to be symmetric with respect to the polar axis because, again, knowing the characteristics that we're dealing with cosine, right? But let's do the test anyway to verify. So, again, if we do R negative for both, right? So again, the theta equals pi over 2, right? So, if I do negative R equals 2 plus 5 cosine negative theta. Now again, cosine is an even function, so cosine of negative theta is the same as cosine theta. So we're going to get negative R equals 2 plus 5 cosine theta. Now this, if you multiply by negative 1 on both sides, you get negative, negative, and obviously it's not the same. So it fails the test for symmetry for theta equal to pi over 2. Now, again, remember, failing the test doesn't mean that it's not symmetric with respect to theta equal to pi over 2, okay? Just keep that in mind. But let's go on to the next one. So let's replace theta by negative theta and see if it's symmetric with respect to the polar axis. So we get what? We get R equals 2 plus 5 cosine negative theta. And again, because this is an even function, we get R equals 2 plus 5 cosine theta. Because again, cosine of negative theta is the same as cosine theta. And so we do get the same thing. So it is symmetric with respect to the polar axis. All right, so now that we know that it's symmetric with respect to the polar axis, what's next? Well, zeros. So let's solve for when R is equal to 0. So 2 plus 5 cosine theta is equal to 0. Of course, we subtract 2 from both sides and then divide by 5. So we get what? Cosine theta is equal to negative 2/5. Now, it's negative, right? So it's negative 2/5. So this is going to be what? It's going to be in the second quadrant. Okay? So let's see, we're going to get 0. So in cosine of, let's see here. Yeah, so that'll work. Yeah, it's within the range, so we're good there. And we can solve for this, right? So if I do theta equals cosine inverse, because this is not a nice angle here, so this is going to be negative 2/5. Okay, so let's see what we get. So inverse, okay, so inverse cosine of negative 2 divided by 5. And we get 100, oh, is that right? Just want to make sure I'm in the right. 113.57 degrees, I believe. Let me just double check. Yes, yes. So it is 113.6 approximately. So that gives me 113.6 degrees, which is going to be, again, it's going to be in the second quadrant. So it's going to be like here. Okay, so that's when it's going to be 0. Okay. Now, is that the only place it's going to be 0? No, because it's going to cross at more than one angle. Okay. In fact, what happens here is, let's see here. Is there anything else? Is that the only one? 1.98. Let me double check. I just want to double check. Just to make sure I'm not missing anything. So I'm going to go. Yes, okay, that's right. Okay. So they have it in radians. I just wanted to make sure that my answer was the same thing. So yeah, they have 1.98 radians, so that's this approximately the same answer. Okay, so now maximum value. Okay, so the maximum value. Okay, now remember, it's going to be 0 at this angle, but this is not the only angle that it's going to be 0, because remember, it's going to have a loop. So it's going to cross the pole twice. Okay? Okay, so now maximum value. Okay, so we want to know when the maximum value is. This is a plus. So the maximum value is going to happen when this is 1, which happens at 0. When theta is 0. So when theta is 0, again, let's maximum of r, the radius, is going to happen when theta is 0, and when theta is 0, this is 1, so that's going to be 7. So r is going to be 7, comma 0. So let's plot that. That's going to be here, 7, comma 0. So angle 0, there it is. Okay. Now, what about, again, some other points that we're going to want to know. Pi over 2. So when this is pi over 2, this is 0, which means this is going to be at 2. So at 90 degrees, this is going to be at 2. Okay. Now, at 113, it's going to be at 0. So where's it going to be at pi? When this is pi, this is going to be negative. So at pi, this is going to be negative 1, which means negative 5, so it means this is going to be negative 3. So it's at 180 degrees, right? 180 degrees, it's going to be negative 3. Boom. So it's going to cross here. All right. Now, at 3 pi over 2, guess what? Because it's symmetric about the polar axis, this is going to cross here too. Okay. So now I already know what this looks like, right? Just from the characteristics. Okay. So again, once you practice with these, you'll get a better feel about this. Okay, but let's go on. So we've got some points, and again, remember where this happens, right? So this is 0, pi over 2, 113 degrees, right? 113.6 or 1.98 radians. And then at pi, now at, so again, at 130, so this is going to be 113.6. So I want to see something here. So if I subtract 180, that's going to be 56.4, right? 66.4. Okay, and so I think at 246.4 degrees, I think it's going to hit zero based on my calculations. We'll see in a minute how that works. Okay, so let's do, okay, so now that we've got these points, right? We found the zeros, we found the max. I found some other points at the different quadrantal angles, right? 0, pi over 2, pi, 3 pi over 2, and again back to 2 pi. Okay, so now let's fill out our table. Okay, so let's start with the common angles. Okay, so we're going to go with, of course, 0, pi over 6, pi over 3, pi over 2, right? And then we have 2 pi over 3, right? So we got 3 pi over 6, 4 pi over 6, yep. And then we got 5 pi over 6. So we got 5 pi over 6, right? And then we got pi. And then we got 7 pi over 6. And then we got 4 pi over 3. And then we got 3 pi over 2. Okay, so let me see if I didn't miss anything. Okay, good. And then 5 pi over 3. So 5 pi over 3. And then 11 pi over 6. And 2 pi. Okay, so let's fill in the numbers that we already know. So at 0, we're at 7. At pi over 2, we're at 2. At pi, we're at negative 3. And then at 3 pi over 2, we're at 2. Or hold on a second. 3 pi over 2. Okay, that's... Yeah, that's true. Yep. Okay, so at 0, it's 1. Yeah. So then, what else do we know? And then 2 pi, it's back to 7. Okay, so let's fill in the rest. Okay, so again, with the 60-90, with the 60-30 angles, These are all going to have reference angles of 30 or 60, so we can use cosine. So I'm just going to fill in the numbers with the decimals. And again, you can plug these in on your own and do them. We've done enough of these, you should be able to do them. 6.3, 4.5. 6.3, 4.5, and then 2. And then negative 0.5. So negative 0.5 and then negative 2.3. Okay, and so it's filling in nicely. And then negative 3 and then negative 2.3. So then it's going back down. And then negative 0.5. Yeah. And then 2, right? And then we go to 4.5 again. And then it's back up to 6.3 and back to 7. Okay. So now, once we plot these, what you're going to find, and I'm not going to plot all these points, but again, if you plot these on a polar grid, it starts here. Okay. So it's going to go up like this. And then it's going to come down. And right back. Okay, and so that's one revolution on the unit circle, right? From 0 to 2 pi. So that's one trace. Okay. Have a great day.